All right, y'all. So, section 2.5, we're going to talk about these ideas called quartiles. Okay, so the first quartile, we're going to call it Q1, and it's going to say about a quarter of the information is going to fall on or below Q1. The second quartile, y'all, the second quartile is just the median. So, half of our information is going to be below the median. And then the third quartile, Q3, says about three quarters of the data is going to fall on or below Q3. So let's see what we can do here. We're going to find the test scores of 23 students. We want to find the first, the second, and the third quartiles. Y'all, the first thing I'm actually going to do, I'm going to find the median. If y'all remember what the median is the number that is in the middle. Okay. So the way I'm going to find my middle number, y'all, is I'm going to say, look, let me underline the first number and the last number, and the second number and the second to the last number, and the third number and the third to the last number, and the fourth number and the fourth to the last. And I'm going to keep playing this game, y'all, until we find our middle number, which happens to be 80. There is our median. Okay. Now, let me show you how we're going to find Q1. Q1, y'all, we're going to look at all the numbers smaller than 80. And we're going to do the same thing we did before. We want to look for that number that's in the middle. So let me take the first number and the last number, number, second to the last, third to the last, fourth to the last, fifth to the last. The middle number of that set is 70. And then the way we're going to find our Q3, y'all, is we're going to look at all of these numbers and we're going to play that same game. So look, 81 and 99, 83 and 97, 85 and 96, 85 and 95, 87 and 92. My Q3 here is 90. Okay. So we found our Q1, Q2, and our Q3. Those are our first quartile, second quartile, and third quartile. Now, what I'm going to do, y'all, I'm going to scroll down. We can do this using our calculator as well, and I'll show you what we're going to do in a minute. Okay. I'll show you how to do that in a second. But let's take a look here, y'all. We're going to find something that we call the interquartile range. Okay. The IQR. The IQR is going to be our numbers Q3 minus Q1. So we're going to do a couple of things, y'all. I'm going to make some labels here just so that we know what it is we're doing. So my Q1 was 70, our Q2 was 80, and our Q3 was 90. Okay. And what we use the interquartile range, y'all, is to find what we call outliers. So outliers are numbers that are either really, really small compared to the rest of the set or really, really big. Okay, there's a couple of steps that we want to do to find our outliers. Number one says, can we find Q1 and Q3? We have that. Q1 is 70, Q3 is 90. Okay, we want to find the interquartile range. So y'all, we're going to take 90 minus 70, that's going to be 20. Okay, we have that. We're going to take that number 20 and we're going to multiply it by 1.5. That's going to give us 30. Now, we're going to have what we call like two boundaries, a lower bound and an upper bound. The way I'm going to find my lower bound, y'all, we're going to take Q1 minus this number 30. So Q1 was 70 minus 30, that's going to give me 40. And my upper bound is going to be Q3, which was 90. We're going to add 30, that's going to be 120. So look what it says right here. Any number smaller than 40 is going to be an outlier, or any number bigger than 120 is going to be an outlier. So if I have a number smaller than 40 or a number bigger than 120, that's going to be an outlier. So in this part, it says, can we go back to that first problem we did with the 23 people who took their tests? Do we have anybody who scored less than a 40 or more than 120? So if I come back over here, anybody less than a 40, the 31. Nobody made more than 120. So the only outlier we have, y'all, was, 31. Okay. Now, we're going to have something called a box and whisker plot. Okay. So we're going to make a box and whisker plot. I'm going to show you how we're going to do that, y'all. We're going to have a 5-number summary of our data set. So y'all, I have my calculator right here. Let me get rid of this. Boom. Let's go to stat. And if I go to my lists, y'all, so actually I can do it like this. Let me get out of here. Let's go to second list. And if I go to list 1 and enter that in, okay, that's actually a different list. Okay, let's enter our list in. So I'm sorry, let's do this. Let's go stat. Let's go to edit. Let's clear that list here. Let me hit clear. Boom. Okay, let me scroll up, y'all, and I'm going to put the list of my numbers in here. Okay, so I'm going to scroll back up to the top, and I'm just going to enter these guys in. So, y'all, I'm going to be real careless to make sure that I don't, yes, I said careless, to make sure that I don't make any mistakes. 67, 67, 69, 70, 70 again, 74, 75, 78, 79, 79 again, 80, oops, sorry, 80, not 81, 80, 81, 83, 85, 85 again, 87, 90, 92, 95, 96, almost done, 97, 99. Okay, 99 problems, right? Okay, so now let's get out of here. Let's go back to our stat. We're going to go to calculate. We're going to calculate our one variable stats. All right. Okay, so look, y'all, if we start to scroll down, we got some pieces of information here. We know that our lowest number was 31. There it is. We know that our Q1 is 70. We found that earlier. Our Q2 was 80. Our Q3 was 90. And the biggest number we had was 99. So the reason why I'm bringing that up, y'all, is when we're going to draw our box and whisker plot, it's what we call a 5-number summary. Has the lowest number, the Q1, the Q2, the Q3, and the biggest number. The lowest number, y'all, is always going to be the first dot. The biggest number is going to be the last dot. So, y'all, what I'm going to do here is I'm going to kind of label a scale. Let me get my calculator, my pen going. Okay. The smallest number we had, y'all, was 31, and the biggest one we had was 99. So, look, I'm going to go 30, 40, 50, 60, 70, 80, 90, and 100. Okay, so when I draw this thing, y'all, I'm going to put a dot right here. That's going to be at 31. Now my line is going to go all the way until I hit Q1. Q1, y'all. So again, just so that we can see, let me get my calculator again. Q1 was 70. Okay, that's going to be the first part of my box right here, y'all. Okay, the box is going to look like this. My box is going to end at Q3, which was 90. I know it's supposed to be a little bit shorter, so we'll fix that. Boom, right that. Here is my Q2, and my maximum number, y'all, is going to end at 99. That's 90, 80, 70, and that's 31. And that's how we draw a box and whisker plot. Okay. Let's see what else we got here. Okay, we're going to talk a little bit about percentiles. So, what is it? How do we find a percentile? And what does a percentile mean? So, let me tell you first what a percentile means. It says, look, if we're looking at the weights of babies, right? So, look, we got a 6-month-old here, and it says the weight of a 6-month-old is in the 91st percentile. That means that that baby weighs more than 91% of all the other 6 months olds that they studied. Okay, that's what a percentile means. So, how do we find the percentile of a particular number? The way we find a percentile of a particular number, we're going to take all the numbers that are smaller than that number. We're going to divide it by the total number of values we have. We're going to multiply it by 100, and we're going to round to the nearest whole number. So look what it says here. Can we find the percentile that corresponds to a grade of 87? So let me show you how I'm going to do this, y'all. First thing I'm going to do, I'm going to scroll back up here. Sorry, I got to scroll back so far. Okay, we're looking for 87. Okay, let's do this so that it works easy breezy, cover girl. First thing we want to do, y'all, we want to find the total number that we have. Well, they told us the total was 23. Second thing, since we're looking for the percentile of 87, we're going to count all the numbers smaller than 87. So these and these up here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, so look, let me scroll back over here. How many numbers were smaller than 87? I believe we said 16. What was the total? We believe we said that was 23, and we're going to multiply that by 100. So the first thing, 16 divided by 23, multiply it by 100, and then round to the nearest whole number. Y'all, that should be 70. So that's what we call the 70th percentile. So that means that whoever made an 87 did better than 70% of the rest of the students. Okay, that's all that 87 means, or the percentile means that they did better than 70% of the students. All right, let's keep moving down here because I think, yeah, there's one last part, y'all. We're going to talk about something called the standard score. Okay, there is a formula, my friends, for the standard score, and I'm going to tell you how we're going to use this. So standard score says we're going to take a particular value minus the mean, and we're going to divide it by the standard deviation. So what does the standard score tell me? The standard score tells me of a particular number, tells me how many standard deviations is that value is from the average. If we have a z-score of -2, that means that we're 2 standard deviations below the mean. If we have a standard deviation of 1.5, that means we're 1.5 standard deviations above the mean. Okay, so let me show you what we're going to look at here, y'all. I'm going to scroll down and we're going to do this last problem. And it says from the table below shows the mean heights and standard deviations for a population of men and women. Compare the z-scores for a 6-foot tall man and a 6-foot tall woman. Okay, so look, first thing we're going to do, y'all, we're going to find the z-score for a man. Okay, the formula says this is what we're going to use. X minus mu divided by sigma. These are my values. Okay, and I'll show you what all these things mean. So first thing we're going to do, what does X stand for? X stands for 6 feet. But if I look over here, everything is in inches. So 6 feet is the same thing as 72 inches because we can take 6 times 12, give us 72 feet. So let's find the z-score, y'all, for a man. We're going to take our value x, which is 72. We're going to subtract 69.9. Y'all, I'm going to give you a strong recommendation. Put this, folks, in parentheses because that's going to be the first thing we're going to do. And then we're going to divide it by our standard deviation, which in this case is 3. So I'm going to take my calculator, 72 minus 69.9, and I'm going to divide that by 3, and I'm coming up with 0.7. I'm going to tell you what these values mean in a second, okay? But there we go for a man. And now let's see if we can find the z-score for a woman, okay? The woman is still 6 foot tall, so her height in this case is still 72, but her mean, or the mean for height for women, is 64.3, again, parentheses, and we're going to divide that by 2.6. So let's do these calculations. 72 minus 64.3, and let's divide that by 2.6. Y'all, I'm going to go to 2 decimal places here, 2.96. Okay, so first thing, what do these values mean? Number one, both of those z-values, y'all, are positive. So that means that these heights are above the standard, are above the mean. The first one is 0.7 above the mean, and the second one is 2.96 above the mean. Okay, so what does this tell me? This tells me is that a man who's 7 foot tall, that man is taller than the average person, but he's only taller by the average person by a little bit less than 1 standard deviation. Now, a woman who's 6 foot tall, She is taller than the average height of a woman, and she's almost 3 times the height or higher or taller than the standard deviation of a woman. Okay. Because these two values were positive, that means that they were taller than the average. Had they been negative, that means that they would have been shorter than the average. Okay. And this is how we find our z scores.